Okay, now that we have set up our definition of what subtraction of fractions is, and by any means subtraction of any numbers, let's go ahead and apply that to a couple of examples. We're going to do actually two different methods. First, we're going to take 17 and 2/5 minus 7 and 3/4, and we're going to solve this by just turning these into mixed numbers and solving them like a regular fraction. So in this case, what we would have is we would do 17 partitions of 5. So remember, that is 17 times 5. And then we have these 2 left over, so that is plus 2 over 5. If you do the same thing with 7 and 3/4, that's 7 partitions of 4, so 7 times 4. And 3 left over, so you add 3. And that is over 4 partitions. So if you multiply these out, this actually equals 85 plus 2. And 7 times 4 is 28 plus 3. All right, so when we put that together, then that means that we're going to have 87 over 5 minus 28 and 3 is 31 over 4. And now we go ahead and do the same thing we would for addition. We need to turn these into equivalent fractions or with an equal partition. So 5 times 4 is 20. And we're just going to write this once. Why waste time writing it twice? Now remember, we need to, if we're going to multiply this by 4, we need to multiply 87 times 4. So 87 times 4 minus, because remember we're subtracting this, and then 5 times 31. So basically what happens now is if you simplify this, 87 times 4 is 348. And 5 times 31 is 155. And again, it's over 20 partitions. And when you simplify that, you get 193 over 20. Which, if you find out how many 20s go into 193, it's 9 and 13/20ths. But we'll worry about that later. So that's one way of doing it. You could turn it back into a mixed number, or you can leave it just like this. We'll go ahead and leave it like this. So there's another way we can do this, and that is by splitting up the wholes and the fractions and dealing with them separately. So remember what we talked about before. This is the same as saying 17 plus 2/5, because it's 17 wholes plus the leftover of 2/5. And we're going to be subtracting that from 7 plus 3/4. So because of associative property, we can actually regroup these or associate them differently. So we can say that this is 17 minus 7, and we're going to add that to these being subtracted. That would be 2/5 minus 3/4. The only problem here is, remember, when we have subtraction, we have to find out which one is greater than. Well, in the order that it is written, if we force the common denominator and get 5 times 4 is 20, and then do our cross multiplication, 4 times 2 is 8, and 5 times 3 is 15. Well, right now, based on what we have defined and what we know, we can't do this. Okay? We can't take 15 from 8. So how are we going to fix this? Well, we're going to start off the same way. We're going to split these up, 17, or actually we're going to, just like what we do when we borrow, we're going to borrow one and we're going to add it to the fraction. So now this becomes 16 plus 1 and 2/5. And of course 7 plus 3/4 stays the same. And again, the same thing. We're going to do 16 and group it with the wholes, so minus 7 plus, now this becomes 1 2/5 minus 3/4. And obviously we can do this now. So remember how we get this into an improper fraction? Okay, this is the same as saying 1 times 5 plus 2 over 5, which is going to equal 7/5. Okay, so 16 minus 7, that's easy. We can take care of that. That's 9. Now we just need to deal with the fractions. We're going to take our 7/5 over here, and we're going to write that as 7/5 minus 3/4. And I'm going to keep working on down so you can see the progression. Again, forcing the common partition, so 5 times 4 is going to be 20. And then doing the same thing, our cross multiplication theorem, theorem 2, 4 times 7 is 28. 5 times 3 is 15. And then simplifying that, 28 minus 15 is 13 20ths. And of course we've been bringing this 9 down each time. Well, remember, 9 plus 13 20ths is the same as saying 9 and 13 20ths. So there's our answer, which is the same if you did 9 times 20 plus 13 would give you the answer you had up above of 193 over 20.